Hello guys, so today we will learn about the linear sweep voltammetry testing of a battery separator. Battery separator is an important component of battery between anode and cathode, which must be neutral because its work or job is to keep the anode and cathode separate without any side reactions. So LSV testing of a battery separator is usually performed to evaluate the electrochemical stability window, basically the voltage range over which the separator remains inert or neutral without decomposing. If you are charging a battery and separator also react or decompose, then it's not good for the battery. So the purpose is to find the upper and lower voltage limits where the separator plus electrolyte combination altogether is stable, no side reaction, totally inert. And it helps to confirm if separator can withstand operating voltage of intended battery chemistry or not. So if it react with some batteries like sodium ion batteries at certain voltage, then it's not good. So this is also used to evaluate and detect the parasitic reactions like electrolyte decomposition or separator degradation. If electrolyte is decomposed, then we will also be able to see in this test, or if separator react, we can also see in this test. So first is how to make this testing. So place a separator between working electrode and counter electrode. Working electrode, you can use the stainless steel. There should be no active material because you are going to evaluate the separator. And for the counter electrode, you should use the same lithium foil, sodium foil, or magnesium foil for magnesium ion batteries. First, you have to place the lithium foil inside the negative casing, then put the separator, then place the electrolyte, and then put the stainless steel spacer without any active material and close the positive casing. And you should do in glove box if it's lithium or sodium ion battery. And then after assembling and crimping the cell, then you have to start the test. Basically, you have to apply the current and within certain voltage and at a specific rate like millivolt per second. And for anodic stability, you can scan from 2 to 5 or 6, and for cathodic stability you can scan like down to the 0. But here we will focus only on anodic stability because most of the batteries uses from 2-3 volt to 4 or 4.5 volt. So then you can monitor, you will get the data current value and voltage value. You can convert the current into the current density by simply dividing the current by the area of the stainless steel spacer. If there is a rise in the current, then it shows electrochemical decomposition. It could be because of electrolyte, it could be because of separator side reactions. So ideal separator shows minimal current until close to the battery operating limits. If there is a current peak or spike, it's side reactions. If there is no peak, it means your separator is neutral. You can use in the battery. So the practical tips are current response. No peak, redox peak should appear in stable region, only capacitive background current. And polymer separator like PE, PP, PVDF, real limits often comes from the electrolyte decomposition rather than separator breakdown itself. And electrode preparation, use the polished inert electrode to avoid any catalytic effect. And you can repeat this test for 3 times to confirm the reproducibility of the test. So here I am going to show you some examples, real world test data or how it looks. So a lot of people have used this kind of LSV graph. Here is current, or you can also use the current density. And voltage from, I have tested from 2 to 4.5. So there is no big current peak while the voltage increases from 2 to 4.5. it means there is no side reaction. It's good for the separator. And you have also seen these kind of graphs where you see this start from maybe 2.5 volt and goes up, and when it goes up beyond 5 volt, actually it's decomposition of electrolyte. A lot of electrolyte decompose after 5 volt, or they may also react with the separator, but most of the separator are neutral because they are polymers, and this is because of decomposition of electrolyte. So if you see these peaks before 4 volt or before 5 volt, it means the separator is reacting. So here is the real data. For example, when you test the cell, LSV test in the beginning, then it will give you the curve like this, black curve on the axle. So the current drops from OCV, open circuit potential, to the close to 0, then continue and slight increase in the current. There is no big spike. If after finishing this test you do repeat the same LSV test, then the peak will start from negative side of the current and come close to 0 and then continue. So you don't need to worry, as shown in the blue graph. So you don't need to worry. Some people have used this kind of graph like on the left hand side. Some people have used this thick graph on the right hand side. Only this is the difference if you do the test and if you repeat the test. So both gives you the same results. Thank you very much. For how to make the coin cells or how to make draw these graphs, you can see my origin videos or battery assembly procedures. Thank you very much.